Okay, let's dive right in. Have you ever wondered how your food delivery app just knows the restaurant's menu? Or how your weather app gets the latest forecast, like right now? Well, it's not magic, it's a conversation. A very specific, structured conversation happening behind the scenes between all these different applications.
Right? I mean, think about it. If you had to personally navigate the complex, totally chaotic digital kitchen of every single service you use, you'd never get anything done. Can you imagine trying to find one specific file on Google's actual servers? It would be a complete mess, not to mention super insecure.
Luckily for all of us, the internet has this amazing system of incredibly efficient digital waiters. They're there to handle all of that complexity for us. And these digital waiters, well, they're at the very heart of what we're breaking down today. So that digital waiter, it has a name. It's called an API, which stands for Application Programming Interface. You can just think of it as the friendly intermediary that lets different applications talk to each other without causing total chaos. It hides all the messy stuff so one program can cleanly ask for something from another.
Let's really stick with this restaurant idea, because it works perfectly. You're the client. The restaurant's kitchen, the place that actually prepares the food, that's the application or the server. Think of it as Google Sheets. And the waiter? That's the API. You don't need to know how the kitchen works, right? You don't care who's chopping the onions. You just need to talk to the waiter.
And this four-step process, this is exactly how applications communicate. You, the client, make a request. The API takes that request over to the application or the server, which does its thing and sends back a response. Simple as that. So let's look a little closer at what goes into making that request. So how do you actually place your order with this digital waiter? Well, you make what's called a request. And just like when you're ordering food, it has some really specific parts that need to be crystal clear so the kitchen knows exactly what you want. These four things, they make up a standard HTTP request, which is basically the language that most of these digital waiters speak. And what's cool is that each one maps perfectly to our restaurant analogy. Let's break them down. First up, the URL. This tells the waiter exactly where to go. It has parts that are mandatory, like the main address of the restaurant, but it can also have optional parts, like these little query parameters that start with a question mark. You can think of those as special instructions, like telling the waiter, just show me the dessert menu or find me all the orders from last Tuesday. Next is the method. This is the verb, the action you want to take. The two most common ones you'll see are get, which is for retrieving data, and post, which is for sending new data, like when you submit a form or add a new row to a spreadsheet. It clearly states your intention. Are you here to get information, or are you here to create something new? Then you've got the header. This just provides extra details. It's like telling the waiter you have a peanut allergy, or that you want your steak cooked medium rare. It helps the server tailor the response to your specific needs, making sure you get the data back in a format your application can actually understand. And finally, the body. Now, this part is only really used when you're sending something new, like with that post request we talked about. It's the information itself. It's the new recipe you're giving the kitchen, or all the details you just typed into a contact form. If you're just getting data, you typically won't even have a body. But hold on, the kitchen won't just cook for anybody who walks in off the street. It needs to know it's you, and that's where authentication comes in. You can't just have random people accessing your data. These credentials, which can be sent in a few different ways, all prove to the server that you are who you say you are and that you're actually allowed to make the request. Okay, so you've placed your order, your request with all the right information has been sent. Now, the waiter comes back from the kitchen. This is the response, and just like the request, it has a very specific structure. So the very first thing you need to know is the status of your order. Did it work? Was there a problem? Did you maybe ask for something that doesn't even exist? Well, the response tells you this immediately with something called a status code. And this is just a brilliant, simple system. A code starting with a 2 means everything was a success. A 4 means you, the client, made a mistake, maybe a typo in the URL. A 5 means the server had an issue, like the kitchen ran out of an ingredient. It wasn't your fault, so you might just need to try again in a little bit. And when you see a 200, that just means okay. It is the standard, successful response. It's the waiter coming back, smiling, saying your order is on its way. It is the big green light of the API world. So just like your request, the response has a header with some context, like what format the data is in. And if you asked for data with a GET request, the response is going to have a body containing that data. That's your food, delivered on a plate in a nice structured format like JSON. Now, our waiter model works great when you know what you want to order. But what if you're just waiting for something to happen? Constantly asking the waiter, "Is my delivery here yet? How about now? Is it here yet?" That's super inefficient for you and for the kitchen. There is a much, much better way. And this is a webhook. It completely flips the script. Instead of your app having to ask a server over and over and over again, the server just tells you the moment there's an update. It's an event-driven approach, which is perfect for when you need to react to things as they happen, like a new email arriving or a payment getting processed.
Yeah, the difference is pretty simple when you put it like that. With an API, you're peeking out the front door every 5 minutes to see if your friends have arrived. With a webhook, you just wait for the doorbell to ring. This is absolutely crucial for any real-time application, like a chat app, getting new messages instantly.
And the setup is surprisingly simple. All you have to do is provide an address, a unique URL, to the service you're using. You're basically telling that service, "Hey, when the event I'm waiting for finally happens, send the notification right here." You're just giving them the address to your digital doorbell. So, look, if you forget everything else from this, just remember this one thing. An API is the waiter you call on. A webhook is the doorbell that calls on you. One is for making requests, the other is for getting notifications. These two tools, they are the absolute foundation for almost every automated process and connected app that you use every single day. Understanding them means you can start to see the digital world not as a bunch of isolated islands, but as this massive network of constant, flowing conversations. You now get the grammar of that language. So what are you going to do with that knowledge?